Hi everyone. I'm going to make a brief introduction because I'm guessing everyone here knows some background is. If you've heard about Dynamo, he's the project manager for Dynamo, and he's a key Addin designer himself, and I'm sure you've seen some of his posts, pictures, images, and things that he's been doing with the tools he developed himself. And today he's going to talk about very questions on it, SelfAwareFamilies. So with that,
thank you. Hi everyone. Sorry if you came here with the intention to see Matt Jezik. He was originally on the docket for this evening. I'll be filling in for him. Hope not to disappoint. This is, in fairness, is not the world premiere of the day families became self-aware. It was also shown at RTC Europe. So if you saw it in RTC Europe, it's still an open door. But I hope to give it my own flavor here today. So just a word about who this is from. I am just here as a representative of the Conceptual Design Group at Addins. We're a group who have spun up a bunch of other projects that you might be familiar with. My colleagues also made Formit, which is the iPad application, which some of you might have been using. We're all deeply involved in making Dynamo. Several of the developers are up here in the front row. Raise your hands. Mike and Stephen. And we also were the builders of Vasari, which is a sort of a younger child of Revit. All of these are sort of meant to be somewhat provocative and prototypey in their execution and rate of development. A lot of what we're trying to do is raise questions and make proof of concepts to look at what kinds of contributions we can do back to the Autodesk ecosystem with the idea that we try these things out, we get feedback from users, we refine them, we try and work at a sort of a more rapid pace of development than a lot of the hero applications work with at Revit, at Autodesk. So some of the things that we did, for instance, like with Vasari, became our playground for doing a lot of experimentation, things like editable perspective views, a lot of work with energy analysis, and that kind of stuff, slim down UIs. And so that's sort of the context in which a lot of this group works. We're taking over. This class has a sort of ominous title to it. The day families became self-aware. I would like to adjust that a little bit to say that this is really going to be about something a little bit more intimate and friendly. I want to talk about being able to take logic and computation and constraints and parameters and thinking about them as baking the goodness into the families. Taking the peanut butter in your chocolate, putting the ice cream in your mochi, and most importantly, putting the dog in your corn dog. That's what we're going to be covering today, just to put it in context. Also, to put it in context, the standard disclaimer from Autodesk, which I would say if I had a single word, but this I will just give you a link to read through. The stuff I'm going to be showing you is a prototype. It is not a promise of delivery in any sort of our paid applications or products. These statements are being made as of today, June 20th, I think, which is the day today. And you can read the rest. And with that, I want to just give you a quick demonstration of where we're headed with some of this functionality. So, let me just fire up. This is a special build of Vasari 3, which again this is a tool that if you're having with Vasari, it's the Revit-based code with a little bit of flavoring added into it to allow for certain things to happen. And I should have actually had this booted up before, but that's what I got. So what I'm going to do is I'm just going to show you this one family. And I'm assuming with this crowd that everybody here is a Revit expert at some level. People are sort of relative family making gurus. People are familiar with this. Anybody here consider themselves to be a family guru? Anybody? It's okay. It's not pride. It's just, do you spend a lot of time? All right. So what I've got here is a regular or seemingly regular family environment that has 4 adaptive points in it in a circle, and a triangular connection that's being made here that creates tangent connections between circles. Anybody here tried to make tangent persistence in Revit families? Try to make one thing that always stays tangent to another? Who had a really easy time doing that? Simple? No? Okay. So just to show you a little bit about this, so I'm going to take this point and I'm going to move it around. And I'm stretching it and moving it around. And I don't have any other application running, and I don't have anything else working. What do you think it would take to do that in the regular family environment? Formulas, magic, trickery. So just to sort of show you that there's nothing else, nothing up my sleeve. There's just the Revit environment running. So what I want to get to is talking about a tiny bit of change to the code that allows for us to take computational logic, whether it comes, in this case it comes from a small bit of Python code that's been injected into the regeneration cycle of the family. I'm also going to show a couple different ways to put it in there. So this is where we're going to head to talk about these sorts of relationships. But first, more PowerPoint. So, before I start slagging families for not being flexible in the problem, I'll say, families are great. I like families as much as anybody, maybe more so. The behavior of families in Revit are really central, of course, to how it operates. Simultaneity of the representation in multiple views, change it in one place, change it in another, change it in the editing environment, load it back in, and it percolates for everything else. Something that you can exchange to other people in your office. Something that you can put online and exchange with the whole world if you're feeling so generous. And you don't need to script. And this has always been sort of one of the value propositions for Revit, is that you can do these complex parametric relationships without having to code. They have built-in intelligence and behaviors and built-in superpowers, like columns know what level they're on and what level their top is on. Railings know how to behave along certain lines and repeat elements along them. They all have those different superpowers by their category. They're parametric in their local definition, and that is to say that they are flexible within a fairly constrained ecosystem of themselves, of the family. They don't reach out very far, but they're very consistent internally. And they are associative in many ways with the rest of the project. That is to say, you change the exterior size of the family and dimensions that are going to it, we'll stretch with it. This is all sort of background stuff. A lot of you guys know this. It's a powerful tool. This was a spider clip that was made in something like Revit 5. But they're not perfect. They are, I think, at best, an approximation of needs. They will get you very, very, very far in your building project, but oftentimes you will run into a stone wall where the family behavior will not get everything that you need. Whether it's you want to make an escalator and you can't make a stair that knows the floors and the bottom as a loaded family. How many people have seen the escalator that was made out of a column family so that it knew the top and bottom? I always like that one. It's a fixed toolbox, so that means that there's a set number of categories, and they all have their own special superpowers, and we're not adding more on the user level. You get what you get from the factory, and that's it. Scalability, when you get into the more intense families that a lot of people here are showing about how to make, which are great, it gets difficult to either scale their production That is, you need to train up a bunch of people who know how to make these things and help and use them. And also, if you start proliferating them through your project, everything can get pretty slow. Behavioral predictability is not always great. Once you set up how a family is supposed to behave, it is not always easy for a third party coming in to sort of understand how it's constructed. And when you're authoring it, it's not always predictable to know what it's going to do until you actually do it and flex it and do a lot of testing on it. In context, families don't reach out very far from themselves. They know very limited range of where they have been placed. And my favorite is the workarounds. So rather than customizing families when you run into problems with limitations, generally what I see people doing is that they're making hacky workarounds. This one is one of my favorites. The monorail by our esteemed Phil Reed, made out of the railing family. So the handrail on top is, of course, now the railing for the monorail itself. The balustrades are the supports. So whatever this file is, it's scheduling to look really freaky. And then on the left is another railing family that's been made as a louvering system, window shading device. Again, they kind of do what you want it to do, but it's going to play hell with your schedule, and usually for anybody who's a BIM manager in the room, this is going to be a nightmare for people to figure out how to maintain. This is pretty much what I just said. Another issue that can come up with regular family behavior is, we're making buildings, whether or not you're making a big complex curvy Revit piano building, or you're making this straight orthogonal building, you're going to have corner conditions, you're going to have weird end conditions. Your 80% solution will turn into 120% nightmare when you have to go back in and manually tweak all of the edge conditions for something. Having the ability to really have tighter control over rules is needed in almost all projects. That isn't to say that you can't do complex systems that do weird things. I made a little cottage industry for myself of showing how you can do that sort of stuff. You can do super complicated stuff with families right out of the box. I'm not going to say that you can't. But I will say that it's not always easy. There's holes in where the capabilities are, and as you are all family gurus, whether you raised your hands or not, you need to sort of know the landscape so thoroughly to know where the bodies are buried and know where the inconsistencies are. So this instance here is, so this is a complex surface that I made, that I patterned with curtain panels and have them color reacting to self-similarity. So all the orange ones are actually geometrically identical, although mirrored in many cases, to other orange ones. Yellow ones are identical to other yellow ones. So you can do this sort of complex stuff. However, you need to know this dialogue about schedulable parameters. You need to know this dialogue about how to deal with filters and colors, how to get different shared parameters to get identified by different filters and colorized appropriately. You need to know the difference between shared parameters and regular parameters. You need, what is this one? This is more minutia on parameters and shared parameter properties. Another dialogue on shared parameters and properties. Another one about schedulable properties and calculated values. So it's hard to train people how to do this stuff. There are solutions to this, and there are, of course, other ways to expand the functionality that's available in the family. One big one is Revit API add-ins will add intelligence. Revit API is really fantastic. It's really powerful. It's growing every year. They're adding more capabilities all the time. But many of you are architects or structural engineers or in other ways not a software developer. Revit API can be hard to use. It requires learning C#. You can hire third-party developers, and another very good application that I've seen lately is tweeting about it to Harry Madison. And all of these are very effective ways, but they are not very scalable. if you don't have in-house development staff, it's hard to do this. If you do have in-house development staff, chances are that they're probably pretty overworked. Here's the success story for using the fourth application, that is the Harry Madison Tweet. Julian Benoit at RTC Europe had a tweet about wanting to expand the capability of local families so they knew what the context was of their host. So taking a door and having it report out what its host is, and getting that to show up in its parameters so it can be scheduled. This is great. This is a family that has now been pushed outside of its envelope to know more about its outside context. And there are other computational engines that exist for people who are not necessarily super savvy in coding or at all savvy in coding. Dynamo visual programming for them, I'm a big proponent of, and there's been a bunch of classes about it here at RTC. Visual programming environment to let people access the Revit API and expand the functionality of their families. Python shell, which is another tool which just it makes a thinner wrapper around the Revit API to allow people to code directly into Revit. So, given that there are these different states, there is the regular family behavior that you've got, and you've got these API tools. What if we could take these different pieces and put them together to make families that were able to both be able to update on their own, as regular families do, but also be able to execute basically arbitrary code for whatever it is that your particular needs demanded. What if we were able to get that sort of code to persist in families so that you didn't have to have external API commands to execute whenever you wanted it to happen? And basically, how about getting the tendrils of families to be able to go out and bring more information back into themselves, or information from themselves back out into the rest of the world? So just a quick summary where we're at with what we've got. Most of you are all familiar with regular family behavior. You add parameters, you can link them up to each other, you can make relationships that are all very consistent within the family itself. The normal family regeneration in a project is pretty straightforward. You have relationships that you've created within the family. You load that family into your project, you can populate the model with it. It's very low overhead for Revit to sort of keep track of all of these things because it's not all different geometry. Revit recognizes that you've got the same thing happening in lots of places, so it can handle them very quickly. Instance parameters gets a little bit more overhead because you get a little bit more individuality of family elements as they occur in your project. So Revit has to think a little bit more once you get into instance parameters about what's going on. Now, the pros and cons of this, as we've talked about, it's always up to date. You don't have to worry about whether or not somebody's gone through and made sure that your drawings are up to date with what the latest family is. Everything is going to come up. It associates with the project, and everything is updated all the time. Plugins, this is what I was talking about before. When you have scripts or once-run APIs, you can make all sorts of crazy stuff. This is Nate Miller's Super Shape, which was generated by the Revit add-on that just accesses, that you can type Python script and then generate these things, and they just, bam, they occupy your model, the real Revit elements. The design development cycle for API add-ins can be cumbersome in itself. It's very powerful, but the basic workflow for this is you're making. This is my unpaid endorsement for the cat light, which is a laser pointer that's for cats. It's like $2. Jason. So you write your code, you compile down to the DLL, you fire up Revit, which then loads the DLL, you then execute it, you make sure that it works, and then rinse and repeat until you actually develop the API plugin so that you know that it's doing it. Once the user has it, they distribute it. So it's nice once you have it, when you're developing it, it's usually pain in the ass because there's a lot of cycling back and forth between compiling your code, launching up Revit, executing, making sure you've got something that works. So the design cycle is slow, compile, load, run. The other thing about these once-off APIs is that they are not responding to change, they're not associative. You can make them so, but a lot of them are just fire and forget. So it starts to sort of play a little fast and loose with what's great about Revit, to have the fire and forget tools. And it also does not change the underlying definition of loaded families that are already in there. Getting a little bit further into the sort of the food chain of how you can make these interactions, you can use computational engines. I'm going to particularly talk about Dynamo. There are other tools that are not just fire and forget plugins. There's a process that Revit can take advantage of where once you fire up one of these add-ins, it can monitor the progress of something else. It can wait for events and then make changes to your model. And I'm actually just going to illustrate a little bit about that right now. Bear with me while I do the iterative loop of firing up Revit to show code. Ooh, this fan's really toasty. It's keeping my coffee warm. So here we go. The simplest Revit model you'll see all day. The standard desk chair. So when I'm saying that things like this are associative within the project, what I mean is I can take a family like this, and if I do a dimension between it, bear with me, I mean, I know that you guys all know this stuff, but just to sort of show you the sort of hierarchy of parametricism here. I have these two place families. I can change, I'll change this one. I can change this one to be a different type, and it changes and dimensions will update to follow the changes that happened in a different family in the relationship between them. All well and good. Now, the next thing I want to illustrate is when you have one of these API applications sitting on top of it, and the difference between fire and forget, and then something that tries to stay a bit more associative with the rest of the model. So I'm going to just open up a very small Dynamo script here. How many people here have heard of Dynamo? That's good. So what I'm showing here, for those of you who aren't familiar with it, Dynamo is a visual programming language that allows people to have access to the Revit API without having to know anything about coding. It exposes different groups of functionality in sort of user-legible code. So what this particular definition does is it does something very specific. I've selected a model element, and it's remembered that model element. It's this one right here. And all it's doing is it is detecting where this desk is relative to the origin of the project. And it is going to write that desk's coordinates back to the family. So now I've got a family that knows where it is. And you can just see that here in the distance to origin parameter that I've added. So there's nothing special about this family. It's just got an instance parameter, and it has an API application that's sitting on top of it that is asking questions about where it is in relationship to the origin of the project. So if I run this, it will update, and it'll say 6 feet. Great. And so now, if I move it, it says 6 feet, which means that this is different fundamentally than what families do. It has now become uncoordinated, discoordinated, not coordinated, with the project, which is a Revit no-no. It's very fast because it didn't have to regenerate anything, but it's useless information now. So Dynamo has a button, which then basically changes its relationship to that process. So that if I run it automatically, basically what Dynamo is doing now is it's sitting there still as this sort of overarching umbrella form, but what it's doing is it's kind of like waiting, crouching for something called an idle event. Idle event? Close enough? It's waiting for Revit to stop doing stuff. And then it'll say, oh, can I check around the model and see if anything's changed? Particularly, can I check if the thing that I am monitoring is changed? So now, if you can, I don't know if you guys can see this. This now says 7 feet over here. And I don't want to change anything about my color scheme. So now, with it monitoring this thing, every time I move it, you can see that it updates where it is in relationship to the origin. It's a pretty simple thing, but Dynamo is allowing that sort of flexibility about whether or not you want things constantly regenerating and keeping up to date, or if this is just going to be something that you're going to sort of periodically check in and do something with. So I just want to illustrate that difference. And also that it isn't, you'll notice that it isn't regenerating that number. Now it still says 9 feet even while I'm moving it. And it waits until I go, boop, and now it'll go, okay, now I can check it. So it's waiting. Those are most of the interaction patterns that we've got for how API applications can interact with family parameters right now. So that's pretty good. You can get fairly high fidelity between what's going on in your project and what the API applications are doing. So with the update, you can get responses to changes at the project level. You can update existing family instances and symbols. One thing that it doesn't do is it doesn't really go in and change fundamentally the underlying way that the family is behaving. If you've got some arrays in there, you might be able to add and subtract some pieces to your family. But you're not really changing anything fundamental about how that family is behaving. These coding environments make the on-ramp to getting other people using them a little bit shallower. We'll leave it at that. So now I want to talk about this project that we've been working on called Project Honeycomb. Can't quite remember the origin of that, but I think it's about the rationale that stacks together to make a larger whole. Project Honeycomb is attempting to combine the best parts of both of these worlds, of the sort of always on, always updating, intrinsically related to the project aspect of family behavior, with the ability to not have the confining aspect of you can only do what the factory at Autodesk produces in terms of category superpowers. It takes arbitrary pieces of code and puts it within the family regeneration cycle so that you can have basically standard families that people can just use. They can pull it out of their project browser, they can execute it, but they will have special powers as defined by end users. The way that this is working is, again, it's a similar diagram to what we've seen before, except these two pieces, the scripted elements over here, whether it's Python or C# or design script, or a Dynamo file itself, those get injected into the family environment, and then the family just does its thing like we've been seeing before. So this whole part hasn't changed at all. It's just what kind of information can go to this family definition. So I'm going to show you a quick demonstration of one of these pieces, one of these prototypes. And the UI around this is all, we're just getting it done right now. So, but hopefully this will convey the idea of what we're working on. Oh, wait, I don't want that version. Sorry, hold on one second. Sorry, wrong to sorry. I feel better about waiting for things to regenerate because I just came from Frank Frolick's really, really awesome talk. But Inventor really regenerates. So this build of Vasari makes one small change to any families that it loads up, which is it adds a space within the code of the family itself to take arbitrary pieces of code that I feed it. So I'm going to do sort of a hello world example here. How are we doing? Okay. So what I've got here is, I've got 2 lines, nothing crazy. This happens to be in the massing environment because that's my comfort zone. But you could do this with any family environment that you might think of. And what I'm going to do is I'm going to put in a little bit of logic into this family that you could theoretically do out of the box, but this is just as an illustration of a different way to interact with it. I've got a little plug-in here called Manage Family Scripts, which is our little special secret sauce for, taking the peanut butter, sticking it in the chocolate. So what I'm going to do is, actually no wait, before I do that, I'm going to show you what the piece of logic is that I'm going to put into this. So here I've got also a special build of Dynamo. And what I'm going to do is I'm going to take my little hello world file called 2 lines. I'm just going to open it up because this is the same thing as Vasari. It's the same kind of node language. It's the same way of hooking things up. It's the same selection metaphor. So a lot of you who've already used Dynamo, this is the same tool for authoring, if you will. So here I've got a couple of selection nodes, and what they have done is they already have saved IDs, which means that I've taken this, I've gone click change, and I've picked this line, and I've picked this line, and I'm going to array XYZs on those curves, and I'm going to make a line between them. And here, just to illustrate what that looks like, I'll run this. Ta-da! So, it doesn't do anything crazy. And remember, I'm not running in automatic, right? So if I take this point and I pull it up, you have a bunch of stuff that was created in the model that has no association with any of the other stuff in the model. This is a fire and forget process, right? If I run it automatically, it'll update. And if I move this line, again, you'll see that I'll move it and it'll update. But notice this one thing. When I'm moving this guy, wait, click, update. Wait, click, update. That's the idle. That's waiting for pass, ready. So I'm going to close this out, and now I'm going to show it all of the same pieces of logic going together in a slightly different way. So I'm going to open up that same file, 2 lines, 2 dumb lines. And the add-in that I'm going to open this time is that Manage Family Scripts. And now, rather than having it run as Dynamo, picking up that file and waiting for the idle loop and running, what I'm going to do is I'm going to inject this in. So I'm going to go load from file. I'm going to pick that 2-line Dyn. And you can see here it says references, or refs is defined. So my Dynamo file already had selected those 2 elements. So I basically already authored this script to look for particular elements in this file and have a certain association with them. So after I've loaded it and it recognizes that these things are defined, I go done, it goes bam. It looks like we're at the same place as before, right? I don't have any external API application running now. I can pick this point, and you didn't see that? So it's kind of a subtle distinction, and I'm hoping that this can play with this audience, because if it doesn't play here, it's not going to play anywhere. That is a Dynamo script running inside of the generation process of the family, which is very, very close to the heart of the whole process for families. If I go and I take this now and I save it, Oh, here, I'll just open up the one that was already, oh. Let's open the one that I did before. Loaded. I open it up, I've got this guy, it's already got that script loaded into it. I now have a family that has behavior that is not defined in any other way that you could through the UI. One of the efficiencies about this is that it actually gets really fast because it doesn't have all the sort of crap and overhead that comes from when you're trying, you want to get to an end product, but you need to basically assemble a bunch of other Revit tools to get you to that end product. When you do that, that means that Revit also has to re-execute all those other things that you're using to try and get to the end product. When you use a computation framework like Dynamo or Python or any other coding language, it's much more efficient in its execution, so you can do more complexity without getting into all the sort of the nitty-gritty of Revit. Revit's great because you can do all of that stuff directly through the UI, and you don't have to be a programmer to do it. But it does introduce some inefficiencies. I'm not going to say that. All right, I'm going to go through a couple more examples. We just sort of were casting around for different examples for how to demonstrate this kind of execution. And one of the examples that we were looking at was, and I apologize to whoever did this one, but somewhere in the process we lost track of whose project this is. Sort of bad mojo for me to show it, but what I want to illustrate about it is that this is not super crazy architecture. You know, it's got a bit of a bonus to solve, which is exciting. The thing that's interesting about it to me is that this connection detail on the column is a tangent relationship here with the column. So you remember that thing that I started off with? This is that relationship that it's trying to make. And the funny thing about it is that it's going to be different everywhere along here. In order to find that tangent relationship between these two supports and that curtain system, either you're going to have to manually go in and tweak them, or just say close enough and let the guy with the wrench figure it out when he shows up there, which you know always ends up really, really working out well. So for this one, what I've got is a slightly different way of looking at how to load in code. So I'm going to take base file, which is just sort of the givens of the situation. I've got a column, I've got a circle, I've got a radius definition here, and I've got whatever that point is that would be the connection to my curtain system. But this time what I'm going to do is I'm going to load in a piece of Python code. And a couple of things to note about this. I am not myself a Python writer, but I can tell in looking at this that there isn't actually really anything in here that refers to the Revit API. It doesn't really get deeply into the Revit API because it actually, for those of you who are familiar with this stuff, it doesn't have any import statements at the beginning that actually call the Revit API. And Stephen, correct me about this when I get it not quite right. But when this script executes, it's already going to be inside of the Revit process, so the whole access to the Revit API is already given. Okay, we'll go with that. So what I'm going to do is pretty much the same process that we were looking at before, which is I'm going to go into my Addin, my manage family scripts, and I'm going to go load from file. So I'm going to go browse to that file that I was looking at before, tangent segments. I'm going to open it. This one is saying undefined. So my script is looking for input. The script is designed to be applied to maybe different environments. It doesn't need to have embedded in it any knowledge whatsoever of the Revit file that it will eventually be loaded into. So I've loaded it into this Revit file, and now it's saying, I need a little bit more information. So I hit refs, And it's going to tell me that I need 4 points. I need to pick 4 points in order to tell this thing enough about what it needs to do to execute. So I go, okay. And I go, 1, 2, 3, 4. All right, so I got all of them in there. And it says references defined. Let me say done. And it executes. And so what I've done is, same as before, I've taken a bit of code, I've given it a little bit more information through the UI to identify what pieces are important, and now it has into the family, and it'll now be part of that regeneration cycle. So now you can see, again, you've got this sort of snappy behavior. Like so. All right, I think I'm going to do one more example. Get into something a little fancier. We'll skip that one. And we can see trusses at the end if we have time and want to talk about it. So we were looking at some fairly simple ones before with the 2 lines scripted, right? Let's do the same thing, but look at a slightly more complex incarnation of this. And what I want to do is I want to look at how, once you sort of get your head around the idea that you can take these sort of scripts and put them through into a regular family regeneration cycle, how does that now play with the rest of the BIM ecosystem? Because so far this has all sort of been isolated, but because they're families, the whole point is to put them in relationship to the rest of the world, right? So I'm going to get my 2-line AC. So same thing as before, I've got 2 lines. This time it's an adaptive component rather than a mass family. So I've got 1, 2, 3, 4 points for placement of this family. And just take a look at the Dynamo script that I'm going to use to inform this model. Open. This one's a little bit more complex, and it's going to make something that's more interesting. So here again, I've got, I'll show the workspace too. I have that same set of initial relationships as before. I've got my 2 curves that are being selected. I'm going to make an array of points along each one of those curves, and then I'm going to connect them with a line. So we saw what that looked like before. It was pretty straightforward. Then I'm going to add another layer of information onto it. And just so you know where this is going, I'm going to make a 4-point roof component that I can put into a project. I'm going to just make a placeable component that does something a little bit more sophisticated than a family would usually do in order to make something for a dedicated project environment. Just to sort of walk you through a little bit of this. And one of the things that I've been kind of conscious of lately is, at first, when I saw the sort of the spaghetti wiring diagrams for Dynamo, I did not come into Dynamo from sort of a coding or a grasshopper background, and I always sort of took these things to look like a big massive spaghetti, hard to sort of decipher. If you are going to try and walk somebody through a family definition that does anything even moderately complex, it's always informative to sort of step back and try to do that to a user who hasn't made that family. And the thing that's always tricky me about it is that when you make even moderately complex Revit families, understanding them and going in and basically drilling down into how they operate, you have to look at a lot of things that are basically invisible. You have to click around and you have to find things, and you have to decipher what the relationship is to each other. The thing that's nice about these graphs is that they're hierarchical. We're working on actually adding more annotation tools, by the way. But even without the annotation tools, you can walk through it and say, okay, head bone, neck bone, shoulder bone, et cetera, et cetera, et cetera. And it can take a little bit of time, but you can decipher what's going on in them on your own. Long story short, this makes a bunch of lines, and then it subdivides those lines into smaller pieces, and then makes a sine wave configuration over those pieces, and then in the end connects them with splines. So if I just run this definition, you can see some of what that is, and you can see all of what it is. If I go and I'm just going to make some model lines so you can see the full definition. All right, so, not impossible to do in Revit, but, I don't know if you'd want to. So this is what this graph is going to inject into this family. And just to show you a little, and I could run this in auto, and then I could stretch the pieces, and it would wait for the idle. You've already seen it. So I'm just going to back out on this to where we started. And I'm just going to inject this into the family. And load from file. Wave. So this is the same definition. Already has its defined references. Done. All right. So now I've got my family. This is all very passé now. It's all regenerating. By the way, if you did construct something like this in Revit, you would not sit there and go and just have it pop back and forth. You would have like all of the reference points and all of the weird rigging geometry that you would do, and all of that stuff would regenerate, and all of that would, and then we see the little thing turning around. So again, this is the efficient execution of a mathematical formula within the family environment. Now what I'm going to do is, this is just a bunch of lines, right? This is not actually stuff that really makes a lot of sense in the project environment. But these are model lines that I can also turn into reference lines, which is what I'm going to do. So pay no attention to the man behind the curtain. So these are now reference lines. I can now create form elements from them. Pay no attention to the man behind the curtain. And let's see, is this unshaded? So there we've got, here's our getting fairly complex geometry here. I'm still going to have, because the head bone is still connected to the neck bone, everything is still going to move with each other, even though my graph didn't generate this surface. It generated persistent elements that any other user could go and grab these pieces and interact with them as they would any other Revit element, right? So in keeping with that, we can also take this and I can add a divided surface to it. I can, make it a little denser. I can pattern it. I'll give it fishnets because everybody loves fishnets. So there, I've got a little bit of country and a little bit of rock and roll here because we've got a base level of information that was made sort of within the UI. I made two lines that had adaptive pointing at everything, which are really, these are my control interfaces for placing this thing. And then I layered onto it a bunch of information that came from a completely different environment. It was a computational environment that then got passed into it. And then on top of the information that got passed in from the computational network, which was built on user interface or sort of direct manipulation methods, I then layered on a bunch of other tools that are easy in Revit, which is the divided surface and the paneling system. And they're all working back and forth with each other. So now, this is all sort of within this environment, right? So now, what about when it gets into a project? All right, so we have our, I think this is the Revit 2014 Advanced Sample Model Set. And in the grand tradition of computational design, I'm going to do a courtyard roof, which is It's not a pavilion. I'm so sick of pavilions. So I'm going to take that family and I'm going to load it in. I still got 10 minutes before it's an hour. All right. So I've got, there's my guy floating around on my tooltip, right? And this might take a little dexterity. Hold on. I should probably have simplified this model. Let's see. Pick one. I'll do that one. You notice the thing that's slowing down is not my family. No, seriously, I love you, Revit. Some of my best friends are Revit. And let's see if I hit all the right points. Nope. Missed one spot. But I can just keep using it like any other adaptive component where I'd go in, I can pick a new host for that guy. And this guy, pick a new host. Just again, notice that it's regenerating. So there it is. We've got our roof, which is this mongrel beast of computational origin in Dynamo and different user interface level interactions to get something that would be well-nigh impossible to do with the regular out-of-the-box Revit family parameters. What's that? Oh, I think it's because I got something poking through from the bottom. Oh, is that it? Hold on. Section box. There you go. Thank you. So unsightly. This is also not. I'll just. I gotta pick a new host. There. There. Snappy. So anyway. I had a couple other examples that I was hoping to go through just to sort of show the snappiness of this, but believe it or not, they live on Matt Jezek's computer, which lives with some other happy owner in New Jersey who walked off with it from a convention recently. But it's a very cool example, trust me on this. You can make this sort of thing with like 2 manipulatable parameters with a bajillion little facets on it to make a geodesic sphere, and just go whoop, whoop, whoop. It generates really fast. So again, these are prototype tools. One of the things that we're looking for is feedback from people about, where they might go with this. Some of the ideas that we've had about it are the behavior of Dynamo is such that you can take these large pieces of functionality and you can package them up into custom nodes that basically take all the stuff in a long, large green box and squash them down into one little node that takes multiple inputs, which is remarkably like what a family is. If you think about what a curtain panel is, down here in the bottom right, curtain panel, in terms of your interaction with it outside of the family, is 4 points. And all you're doing is you're defining where those 4 points are going. And that's exactly what this custom panel is doing, this custom Dynamo node. Could we just take those custom components and say, make a family on the fly? That sort of thing. So just one more sort of summary diagram, it's a bit of an eye chart, for how this is working. If we're looking at this sort of scripted family instance, which is what we were just sort of walking through the authoring of them, the way that it works is you've got all the basic instance references and object parameters. So that's the line and the adaptive component points. They pass their information into the script. The script then passes its information out to anything else that might be there. The script can also pass its information out to other scripts, presumably, so that if you wanted to fire off other processes from within a family process itself, so every time the family regenerates, it goes and checks a web page for more information and brings it down, or tells another script to execute and do something else, like a regular API plugin, you could do that. And then it has its regular interactions with other family parameters. So who would use such a thing? We'll get to that. So there's two sort of inputs for how these sorts of tools could be adopted, and it depends on what your computation skill level is and what your Revit skill level is. That one piece of Python code that I was showing for the tangency relationship, it had really very little, if anything, to do with Revit in particular. It was entirely about mathematical geometric relationships that were expressed through Python. And then Revit was going to pass in some information, and it was going to pass out some information. So the amount of Revit experience of that coding person could be relatively minimal, but having a large impact on a Revit environment. So on the other hand, what if you are a Revit guru who has no experience with a coding environment? Then that is the opportunity to do something like a Dynamo coding environment where you take the Revit families as far as you can, or as far as you would like to, and then use this sort of functionality to push you over that last 15 or 20% that your families aren't going to get you. So again, there's another distinction to be made here about authors versus consumers. So authoring for families, and this is actually, I don't know how many people have this, it really seems to depend on offices. Some offices don't have anybody touch family content. Like the family content is done by the family content guys who know how to not screw everybody up. Some offices have everybody make content. I'm not sure what your particular situations are. You can have the same situation with this sort of functionality. Maybe you just have people who only handle the scripting, and they are the authors, they're the power users, they're probably people like you. But then in terms of consuming it, it's everyone else. It's everyone else who might be consuming families, which is anybody that's using Revit. The interaction model for that is grab it over here and bring it in. Here, I'll do it again. Grab it over here. Anyway, you get the idea. These sorts of families can live right inside of your family browser. They don't necessarily even need to be shown up as anything else other than a scripted environment. And then the idea again is that you have this computational core, which is just piggybacking on the rest of the BIM environment in order to get all the rest of the downstream goodness. Data, analysis stuff, all the rest of the things that you get out of the box. Risks? Why, sure. So, this is sort of a proposal. This is a prototype. That again, we're looking for feedback. I think that it's sort of a volume dial on what kinds of things could be allowed with this. It could be you allowed to do anything, where your script could go into your Outlook and get all of your addresses and mail all your friends. It said, I just made a family. Maybe something less. Does it reach far out? Does it reach near? Do you put handles on that so that you can control that or not? These are not very different problems than just the regular macro environment. Revit is usually a trusted application within your operating system, so you can do a lot of damage with macros too, as soon as you enable them and let them run. But these are the sorts of decisions that This is one of the things that the Revit development group sort of proper, once you get into sort of the warm, cuddly core of Revit and its development process is, it is necessarily a conservative process because they're dealing with your embassies and your airports. And that process for development needs to be conservative and needs to vet these sorts of ideas to make sure that they are important enough to put in some element of risk into development. So, which leads me to the question of, would you use it? Is this something that would happen? If this functionality was there, are we barking up the wrong tree? And that's an hour. And I would like to, it doesn't have to be right here, but if anybody has thoughts about particular things that they would use this sort of tool for, we have a number of ideas of what we think it would be for. One of the points of doing these prototypes is to say, we were thinking of this, what were you thinking of? Things like, having a door that knows what its host is for fire rating. A lot of what people have been doing with Dynamo have been very informative for us about what kinds of things these sorts of families might be used for, just because they are essentially this representation of this kind of behavior, but that just waits in the idle loop and requires that you have Dynamo already installed and has a few more pieces of overhead for their execution. So in conclusion, again, families are great. I have no problem with them. I would like to expand what they're used for. We'd like to be able to give them more brains. And one of the big things that Honeycomb and that the sort of the Dynamo project in general is trying to do is make ease of creation a priority. There are a lot of people who have very imaginative ideas about computation and about logic and about rules that have not traditionally felt empowered to enact them. And we feel pretty strongly that our users are the smartest people around. And the fact that not everybody is going to go and learn how to program in C# doesn't mean that those sorts of rule-based language and that sort of thinking shouldn't be exposed in all the tools that we provide. And also the ability of using families as a vehicle for getting this sort of information and this sort of design performance around seems like the right avenue to choose because it is sort of the common language of the BIM universe. So with that, I'd like to open it up to any questions. Also, I might be pointing to a couple of these guys up in the front row, Mike and Steven, if it gets into sort of technical questions, just so you know. Robert.
So, does this open the door to the problem you and I talked about ages ago about getting that recursive logic of like?
Oh, for sure. Yeah.
Just gotta burn up our
So Robert's asking if this gets into the question. We did a class a couple years ago that was making families that use reporting parameters and tried to push them out to the limits of what they could do. There's a reason that reporting parameters don't do everything, and one of those reasons is if reporting parameters worked on everything, you could theoretically create endless recursive loops in the regeneration cycles of your families. Does this open the door for creating endless regeneration cycles? Totally. Yeah, I mean, and this is sort of the struggle again with Revit is just, how big of a firearm do you give people to shoot their own foot off? And there are different philosophies, but again, I mean, I think it's a volume dial. And, reporting parameters are a really clear expression of that they do a bunch of things, but it was conservatively implemented so that people didn't shoot their foot off. I mean, I think you know which side I fall on, but, Both feet. Take off the whole leg. Yes, sir.
So, I'm friends, or is the Dynamo big enough that we could actually plug inside and be in that substrate and at the same time?
The scripts to feed it into Inventor. I mean, I honestly don't know enough about how inventor works. Stephen is nodding vigorously.
Well, there's no reason why you can't.
No reason why you can't. There you go. I mean, the idea of how this works with families was definitely grown out from the idea of how families work. Like, families have a very particular life cycle, and they have a very particular regeneration loop. And this was built around that idea of like, there's a sweet spot to get in there in order to execute this kind of code. You know, I don't know, it seems like it's an idea that would percolate to other parametric systems that have that sort of component-based idea. Sure. Yes, sir.
What happens if the end user doesn't actually have Dynamo on that workstation?
Right. So if I had this special build that was on another machine and I didn't have Dynamo on it, it wouldn't matter. That execution, I mean, for this prototype, it's, you know, it's sort of a question of how you would implement it. Like, are you going to support Python? Are you going to support Dynamo? Are you going to support, you know, Design Script and C# and all these other ones? There would have to be built into Revit, you know, some understanding of that execution. But part of the point of this is that you don't need the separate plugin. You would need some aspect to do the editing. You know, if you were going to be editing Python, you would probably want a decent Python editor to do it, in the same way that if you were going to edit a Dynamo file, you would want Dynamo to do it. But there's no necessity for the authoring engine to be there for the consumption of it. I'll come back. All right, we're on repeats already. I'll go back to Robert then. Robert.
So, since you use the plugin to integrate the script with the family, does that family execute on a non-special build?
It would not load in Revit. This is like this is a sterile stream of. It would give you the same warning as when you try and open a 2015 file in 2014. It has additional parameters and additional pieces of data in it that, you know, other versions won't recognize.
Is the plan to actually put that script option not in the project,
What kind of things are you thinking of?
just being able to run multiple Dynamo scripts, not like we put it out the middle of the project.
I mean, we've been looking at it primarily on families. I mean, the logic of it kind of, you know, if you want to put this sort of computation logic into a project, it seems like it would follow a similar thing. I'm sure that the technical implementation would be fraught in all sorts of other ways, because then the playground is much larger right away. But we've been thinking about it primarily sort of on the component level. Yes?
Could it be equipped into system families? Maybe size specifically?
You know, as a prototype and an idea, and I don't see why not. But it does become another question of, you know, with families is kind of an easy way to express it. Like, you have a separate editing environment to work on families. If you were going to put this into system families, I think it would be, well, there's at least a UI difference where you're going to say, you know, how do you access that? You know, system families are this thing that basically are part of the project level experience. You can't get rid of them. They're a very different kind of beast. I would imagine it would be a different kind of development project, but why do you have specific ideas around system families? Sorry, say that again?
Splitting pipes and ducts automatically.
Splitting pipes and ducts automatically. Okay. Any other questions? Nope. Helen. I didn't. There's a whole other crowd over here. Hi, guys. Well,
where it is host.
right. Not to distance myself too much from, but I'm actually not intimately plugged into the core Revit development process right now. Dynamo's, in the conceptual design team is sort of working parallel to Revit. But the idea with this is that it doesn't supplant or replace built-in Revit features. It works alongside them. It can leverage them when it's appropriate. It can do it, so even this example of just connecting two lines with lines. You could do that with repeaters, right? You could take the repeat, unit, zip, right? You could do that same thing. There are advantages to one over the other in different contexts, depending on what your skill set is too. Like if you know one set of tools, you would use that tool. I would say though that for what I've seen with most of these sorts of family behaviors, if you're not like right in the intended use area of what the behavior is intended for, as soon as you get out of that, it becomes much more efficient in terms of performance. You start to see slowdowns. Specifically for things like repeaters, I mean, in order to do that same thing with repeaters, you would need to have a nested family, which is fine, but nested families will make your files bigger and they will make them slower. Regeneration will slow down. So that's one of the things that we're seeing with like these big wavy curvy lines. I know I could figure out how to do that with out-of-the-box functionality, but it would have a lot of overhead in order to get that one accomplished. So. Right here. I think it exists on 2 computers. 1.5. Oh, yes.
Sorry.
No.
Is this going into normal families or just computational?
This is super exploratory right now. As the disclaimer said at the beginning, don't buy stock based on anything that you see here today. But if there are things in it that you find to be interesting or compelling or you think that are worth pursuing, please let your local Revit representative know. And also, if you have more ideas about what you would see this doing or other ways that you can interact with this, let me know. You can also just email actually the team at Dynamo at dynamo.org, dynamobim.org. Actually, I don't have my email up here, but I'm just going to put it up. Why can't I actually write anything here? That's me. Yeah, so if you have more ideas or other thoughts about this, shoot me a note. Let me know any other thoughts about it. Yes? Oh yeah, actually that was one thing that I was showing, sort of that loading aspect. There was a little drop down so you could load multiple ones. It was one of the things that we were thinking about, is that you could queue them up. There's a lot of kinds of calculations that make sense to execute in series rather than within one thing.
And once these scripts are loaded in, are they testable wrong without
Not in this prototype, but I mean, yeah, that would be like another next step, is to say, you look in the family, you find the script, you exhume it, you edit it, and you put it back in. But we don't have that enabled in this prototypey thing. That's a good observation, though, getting it back out. Thank you all for your time and attention.